Alberta Oil Sands. The Canadian oil sands, also known as tar sands, are one of the largest industrial projects in the world, primarily located along the Athabasca River close to Fort McMurray in Alberta. The sands cover about 140,000 kilometers, that's about 20% of the province of Alberta and about the size of Florida. Oil extractions occur through two major ways. The first picture shows surface mining, and the second picture shows deep drilling called SITU. Typically, oil sand production can be energy intensive as producers drill a well and inject steam into the ground to heat the bitumen until it becomes warm enough to flow. And when mining, producers use steam to extract the bitumen above ground, which produces dirty wastewater in the form of pools. Oil extraction also causes large amounts of greenhouse gas emissions. And here is a short video on SITU oil sand production, and it just gives a little bit more detail into what it is.
In situ. In situ refers to a group of oil sands technologies used to recover bitumen that is too deep beneath the surface to be and too viscous to flow on its own. There are four main technologies used in situ production: steam-assisted gravity drainage, or SAGD, and cyclic steam simulation, or CSS, use steam as a means of reducing viscosity and producing bitumen. Toe-to-heel air injection, or TIE, involves igniting air in a vertical well to melt and recover bitumen. And VAPEX uses solvents to increase the viscosity of bitumen for recovery. In situ production is required for approximately 80% of the bitumen found in the oil sands, and the most commonly used technology for this production is SAGD. SAGD was invented in 1978 by Dr. Roger Butler, a chemical engineer from England. SAGD works by drilling two horizontal wells beneath the surface, parallel to each other, about 4 to 6 meters apart. The top well is injected with steam that heats the surrounding bitumen, reducing its viscosity. This is the steam-assisted part of the name. The less viscous bitumen then drains into the bottom well with the help of gravity and is pumped to the surface. This is the gravity drainage part of the name. The produced bitumen is mixed with hydrocarbons to further reduce its viscosity and is then stored in storage tanks for transportation and further processing. SAGD has several advantages over oil sands mining. SAGD production has less land disturbance and does not result in the creation of tailings ponds. However, SAGD requires large amounts of thermal energy to produce steam. Currently, the vast majority of this energy is provided by natural gas, making greenhouse gas emissions a key concern for the process. In addition, water use is another important concern. The SAGD process requires a significant amount of water, though 80 to 95% of the water used is recycled back into the process. Some SAGD operations also use saline water that is determined to be unsuitable for drinking or irrigation purposes in order to minimize the use of fresh water. That's in situ.
Both extraction methods face a common hurdle. They rely on steam for conventional fuel-burning boilers, leading to greenhouse gas emissions and clean water usage. National Resources researchers propose a solution, DCSG, which is short form for direct contact generation. Injecting contaminated water into a 1,300-degree flame combustion chamber, DCSG shows promise in using less clean water and keeping the greenhouse gas emissions underground. Although direct steam generation is still a few years away from commercial use, it holds potential to transform the oil sand industry towards sustainability.
And here are credits. The narrators for this project were Casey Cook and Brianna French, and it was made as a part of the course ES 110, Environment, Sustainability, and Society at Wilfrid Laurier University.